The second receiver test, sniffing the local oscillator of LMR SDR 1.1. If you have another HF radio or a cheap RTL-SDR dongle, you can verify the SI5351, which is the clock generator in LMR SDR 1.1, is actually oscillating. Place the antenna of a second receiver very close to SI5351 on your LMR SDR board. It need not have to be on the board itself, can be near that, as I'll show shortly. Tune the second receiver to 4 times your LMR SDR's displayed frequency. Example, if the SDR is set to 7 MHz, tune the second radio to 28 MHz. Result, you should hear a strong unmodulated carrier S9 signal. If you don't hear anything, the SI5351 is not initialized, likely due to an I2C communication error with the Arduino. Now I am going to show you how I am testing this in my LMR SDR board and showing that SI5351 is really working. This is the screen of my FT710 radio, and you can see that the S meter is pointing at 9. For checking the signal generation of SI5351 in my LMR SDR board, I have just switched on and connected to the laptop because I don't want to check the full radio. I'm just checking the SI5351. So the frequency in this display is 7131.150 kilohertz, and this is the LMR SDR board, and I have kept the antenna. This is a patch cable coming from my FT710 radio. This is the screen of my FT710 radio, and you can see that the S meter is pointing at 9. Signal is almost 9. That is the signal from the SI5351. That will be 4 times the display frequency on LMR SDR. That's why in 7 MHz it becomes 28 MHz. And I'll tune away from that frequency, and you can see that the signal strength has gone down in the meter. I'll come back again. That's because I'm fine tuning and zero beating on the signal. Now the signal is seen as around 28487, you can see. Now I'll go back and change the frequency in that LMR SDR and check once again. You can watch what happens to the vertical band when I'm going to tune the LMR SDR. I'll move on from here, so my audio may be a little lower. I'm tuning the LMR SDR, and you can see that it is shifting, and the S meter needle also has shifted. You can see that is, as I am tuning the LMR SDR, I am turning the rotary encoder. You can see that the frequency is going away from that. The waterfall you can see is going away. Now I have reached another frequency. I'll stop there and come back. I am back here and I am going to tune it again. See, this is the spot. See, the signal strength has again gone into, you can see it now, it is S9 again, and it is on a different frequency, higher frequency, you can see. So that firmly confirms that the SI5351 clock generator is working. This is the new frequency, 7.151 kilohertz. 0.450 is also there, to be exact. That's the new frequency. I have just changed it by this. This is a rotary encoder, and you can see the green light blinking from the board. That is the CAT control, showing that this is being controlled by the computer. So this is a sniffing test for the clock generation by using my FT710 radio because I do not have a signal measuring instrument like oscilloscope. That would have been best, but this is really okay.